we now discuss the solution of a problem from the section Differential Calculus, and the problem is on to find the maximum of a given function, and the function was given through a determinant. This question has appeared in Joint Entrance Examination Main held on 27th July 2021 in the morning shift. The problem is, let f of x is equal to, it is given as a 3 by 3 determinant whose first row is sin square x minus 2 plus cos square x cos 2x. The second row is 2 plus sin square x cos square x cos 2x. Third row, sin square x cos square x 1 plus cos 2x, where x belongs to the closed and bounded interval 0 to pi. Then the maximum value of f of x is equal to. So we have to find the maximum value of f of x, where f of x is given to be in terms of a 3 by 3 determinant whose entries are the trigonometric functions sin square x, cos x and cos 2x. And the maximum value of f x is to be found for when x comes from the closed and bounded interval 0 to pi. We now discuss the solution of the problem in detail. We are given f of x is equal to a 3 by 3 determinant whose entries are sin square x, cos square x and cos 2x and the constants, and where x belongs to 0 to pi, and required to find the maximum value of f of x when x varies from 0 to pi in the closed and bounded interval. Now f of x is this 3 by 3 determinant, and to evaluate this we will utilize the elementary row operations, and we perform R2 implies R2 minus R1. So in the place of R2, write down R2 minus R1. That means from the entries of R2, the corresponding entries of R1 is to be subtracted. So when it is done like that, the determinant is not going to change. We know this fact, and that is equal to the first row remains as it is, and sin square x 2 plus sin square x minus sin square x is 2, and cos square x minus of minus 2 plus cos square x cancels, minus of minus 2 is plus 2, cos 2x minus cos 2x is 0, and the third row remains the same. We will again perform another elementary row operation. From the entries of R3, subtract the corresponding entries of R1 and write down in the place of R3, and that is R3 is R3 minus R1. So sin square x minus sin square x, you will get 0. Cos square x minus of minus 2 plus cos square x cancels, minus of minus 2 will be plus 2, 1 plus cos 2x minus cos 2x will be 1. So you will get the third row as 0 to 1 as discussed. Now it is very simple. So we will expand this determinant by along the first row. So expanding this determinant along the first row, sin square x into 2 into 1, 2 minus 0, minus of minus 2 plus cos square x, delete that row and that column, 2 into 1 minus 0 plus cos 2x into, delete that row and that column, you get 2 2s are 4 minus 0. So on expanding you will get this one. Now simplifying, we will get this expression. In this we find minus 2 cos square x and 2 sin square x. If you take minus 2 common, you will get cos square x minus sin square x, and that will be cos 2x. So we write now 4 minus, for this 2 cos 2x plus 4 cos 2x. Simplifying, we will get 4 plus 2 cos 2x. This is our fx, and fx will be maximum when cos 2x is maximum. When cos 2x is maximum, when cos 2x takes the maximum value 1. When x is equal to 0, which is included, yes, cos 0 is 1. When x is equal to pi, yes, it is included, cos 2 pi is 1. So the maximum value of cos 2x is 1. So f of x, the maximum value is 4 plus 2 cos 2x, maximum value is 1 in this interval. The maximum is attained at x is equal to 0 and x is equal to pi, and the answer is 4 plus 2 is equal to 6. That's your answer. That is a very simple and straightforward question from differential calculus, and the problem is to find the maximum value of a given function, and that given function was given through a determinant whose entries are elementary trigonometric ratios. I hope that you have understood the solution of this problem, and go on working out some more problems on these lines, and I wish you all the best. Thank you.